Hello guys, welcome back to our channel. Imagine a world where your car not only drives itself, but predicts traffic, avoids hazards, and even understands your mood. Sounds like science fiction? Not anymore. Welcome to Driving the Future. The role of AI in the automobile industry will explore how artificial intelligence is revolutionizing the automotive world, from self-driving cars to predictive maintenance, from smart traffic management to AI-powered manufacturing. Whether you're an auto enthusiast, tech lover, or just curious about what the future of mobility looks like, this video will drive you through it all. So, now explore more on what is AI? And why it matters in automotive. Before we explore how artificial intelligence is transforming the automobile industry, let's take a moment to understand what AI actually is. Artificial intelligence, or simply AI, is the simulation of human intelligence in machines. In simple terms, it's about creating systems that can think, learn, and make decisions, just like humans, but often faster and more accurately. AI isn't just one technology, it's a combination of many. Machine learning, which allows systems to learn from data and improve over time without being explicitly programmed. Computer vision, which enables machines to see and interpret visual information from the world around them. Natural language processing, or NLP, which helps machines understand and respond to human language. And deep learning, which mimics the structure of the human brain to solve complex problems. Modern cars are no longer just machines with wheels. They are rolling computers, filled with sensors, cameras, radar systems, and real-time processors. And AI is the brain that connects all of these technologies. So, why does AI matter in this space? Because today's vehicles need to make decisions on their own. For example, detecting a pedestrian crossing the road and applying the brakes, that's AI. Navigating a busy highway without human input, that's AI. Alerting drivers about engine failure before it happens, again, AI. AI transforms cars from reactive machines into proactive, intelligent systems. And that shift is at the core of innovation across the entire automotive value chain. It also goes beyond the car itself. AI helps manufacturers build cars more efficiently through smart robotics and quality control. It powers predictive maintenance systems in commercial fleets. It enables cities to manage traffic flows with connected vehicle data. Simply put, AI is the foundation for the future of mobility. That's why AI matters in the automotive world and why it's driving the industry into the future. So, next, the evolution of AI in automobiles. To truly appreciate where AI is taking us in the world of automobiles, we need to take a step back and look at where it all began. The evolution of AI in vehicles didn't start with self-driving cars. In fact, it began with small, incremental innovations that many of us now take for granted. Cruise control was one of the first intelligent features, introduced as early as the 1950s. This system allowed cars to maintain a constant speed without driver input. While simple by today's standards, it was a foundational step in automotive automation. By the 2010s, things really accelerated. With the rise of machine learning and data-driven algorithms, vehicles began making more complex decisions, such as identifying road signs, detecting pedestrians, and staying within lane markings using cameras and radar. Then came the big leap: autonomous vehicles. Companies like Tesla, Waymo, Nvidia, Uber, and Baidu began developing self-driving technology that combines AI, real-time sensor fusion, and high-definition maps to navigate complex environments without human input. Among all the ways AI is revolutionizing the automobile industry, autonomous vehicles stand as the most groundbreaking. But how does it actually work? Self-driving cars rely on a network of AI-powered systems that process inputs from multiple sources, including cameras that detect traffic signs, road markings, pedestrians, and other vehicles, LiDAR, light detection and ranging, which creates 3D maps of the surroundings, radar sensors that monitor nearby objects and measure distance and speed, GPS for navigation and location tracking, ultrasonic sensors to detect nearby objects at low speeds. Now let's talk about the 5 levels of driving automation, defined by the Society of Automotive Engineers, SAE. Level 0, no automation. The human is in full control. Level 1, driver assistance, like cruise control or lane keeping. Level 2, Partial automation, the car can control steering and speed but still requires full human attention. Level 3, conditional automation, the car can drive itself under certain conditions, but a human must be ready to take over. Level 4, high automation, the car can handle all driving tasks in specific scenarios, like city zones. Level 5, full automation, no steering wheel, no pedals, and no human input required. Some of the biggest innovators in this space include Tesla, with its autopilot and full self-driving system, which uses AI-powered vision-only processing. Waymo, a subsidiary of Google's parent company, Alphabet, running fully autonomous taxi services in cities like Phoenix and San Francisco. Cruise, backed by General Motors, developing self-driving electric vehicles for urban use. NVIDIA, which provides AI chips and platforms for autonomous systems. Aurora, Baidu, Apollo, Suax, and more, each pushing the boundaries of autonomy. Move on to the AI in manufacturing. Quality control. One of the most visible uses of AI in automotive manufacturing is in robotics, especially with machine vision. These intelligent robots use cameras and deep learning algorithms to see what they're doing. They can detect tiny defects in body panels, ensure every part is aligned perfectly, verify paint quality and color consistency, identify missing components on a production line. Quality control is no longer just about human inspectors at the end of the line. AI now monitors quality throughout the entire production process. Using high-resolution imaging and real-time analysis, it can instantly detect imperfections in welding or assembly, flag errors in electronic systems before installation, cross-check measurements and tolerances down to the micrometer. Several global automakers have already adopted AI-powered manufacturing. BMW uses AI to scan vehicles for quality defects using computer vision. Toyota employs machine learning in its Kaizen-based production systems to improve every detail of the process. Audi has implemented AI-based anomaly detection to monitor thousands of factory sensors. Ford uses AI and AR, augmented reality, for remote quality inspections. Let's move on to AI and in-car experience and personalization. With the rise of artificial intelligence, our vehicles are becoming intelligent companions, learning from our behaviors, adapting to our preferences, and creating deeply personalized experiences behind the wheel. AI enables dynamic user interfaces that adjust in real time. For example, your dashboard layout can change based on the time of day or driving mode. Voice assistants can prioritize information depending on your urgency, whether you're navigating heavy traffic or parked safely. AI-powered voice assistants now understand natural human language, tone, and context. You can say, "I'm feeling cold," instead of "set temperature to 22 degrees. Where's the nearest charging station?" And it provides personalized results based on your vehicle type and remaining range. AI monitors driver behavior to offer custom experiences and safety features, such as adjusting seat and mirror positions based on driver identity. AI doesn't just focus on comfort, it also enhances in-cabin safety. Internal cameras and sensors powered by AI can detect if a child or pet is accidentally left in the car. Using deep learning and historical data, AI can predict your needs before you even think of them. For example, recommending alternate routes before traffic builds up on your usual commute. AI also makes it possible to seamlessly switch between users, thanks to cloud profiles. Imagine renting a car or sharing one in a family. As soon as you enter, the car loads your seating, temperature, playlists, voice settings, and more. Artificial intelligence is not just changing how cars drive, it's changing how they feel. Through intelligent interfaces, predictive features, and real-time responsiveness, AI is putting the driver at the center of the experience like never before. This isn't the future, it's already here, quietly transforming your next drive into something extraordinary. Now, move on to AI in traffic management and smart cities. One of the most effective applications of AI in urban mobility is smart traffic signal systems. Traditional traffic lights operate on fixed timers, regardless of how many cars are waiting. But AI-based systems use live data from sensors, cameras, and GPS devices to adapt signal timings based on traffic density, time of day, weather conditions, special events, or emergencies. In a truly smart city, everything is connected. AI integrates data from smart lights, waste systems, surveillance cameras, EV charging stations, air quality monitors. AI also plays a critical role in urban sustainability. By analyzing transportation patterns, AI helps city planners design better roads, identify traffic choke points, expand bike lanes and pedestrian zones, reduce carbon emissions. Real-world smart city initiatives are already showing results. Barcelona uses AI for traffic light control and pollution reduction. Singapore's Smart Nation program uses AI to track traffic and manage congestion in real time. Los Angeles has implemented AI-based predictive traffic systems to cut congestion by up to 10%. Amsterdam uses AI to optimize public transport and traffic light phasing. Now you can see further challenges and ethical considerations. Let's start with the most critical issue: safety. AI-powered systems, whether in autonomous driving or factory robotics, must operate with an extremely high level of accuracy. But no system is perfect. AI may misinterpret data from sensors that can make incorrect decisions in unexpected situations. Software bugs or hardware malfunctions can cause serious harm. AI systems in vehicles constantly collect data: GPS location, driver behavior, in-cabin camera footage, biometric and voice commands. Another concern is bias in AI systems. AI learns from the data it's trained on, and if that data is flawed or biased, so are the outcomes. AI in manufacturing and transportation also raises concerns about job loss. Automated factories need fewer line workers. Self-driving taxis may replace human drivers. AI dispatch systems reduce need for middle managers. Perhaps the most complex ethical challenge is how AI should behave in life or death scenarios. Imagine a self-driving car is in an unavoidable crash. Should it protect its passengers at all costs? Or swerve to avoid a group of pedestrians? These are called moral dilemmas, and there's no universal answer. Teaching AI to make human-like ethical decisions is still a long way off. As we hand more control over to AI, we risk losing essential human driving skills. If systems fail or go offline, will drivers still know how to take control? Over-reliance on automation can lead to a false sense of security, and that can be dangerous in real-world scenarios. Finally, there's the issue of regulation. Many countries are struggling to keep up with the rapid pace of AI development. Without global standards, we could face inconsistent safety protocols, legal loopholes, unequal access to AI benefits. The journey of artificial intelligence in the automobile industry has only just begun. We've seen how AI is transforming everything from how cars are built to how they move, think, and respond to the world around them. But what comes next is even more exciting, more ambitious, and more human-focused than ever before. In the years to come, cars will not just be modes of transport, they'll be personal mobility companions. Powered by AI, future vehicles will predict our needs before we even ask, self-diagnose and schedule their own maintenance, learn from our preferences, habits, and routines, and communicate effortlessly with smart homes, cities, and even other vehicles. The goal? A driving experience that is safer, more intuitive, and truly intelligent. The future of AI in transportation is not just about technology, it's about people. This transformation opens up vast new opportunities, not just for automakers, but for startups, software engineers, data scientists, UX designers, city planners, and everyday users like you. The future of mobility is being built by collaboration, where technologists, policymakers, businesses, and citizens come together to shape a better way forward. We're entering a new era, not just of smarter vehicles, but of smarter movement, smarter cities, and smarter living. AI is the engine behind this change, and we're all in the driver's seat. The question isn't whether AI will shape the future of transportation, it's how we choose to guide it. Thank you for joining us on this journey through driving the future, the role of AI in the automobile industry. The road ahead is filled with challenges, yes, but also incredible opportunity. As AI continues to evolve, so too must our vision, a vision that puts innovation, ethics, safety, and humanity at its core. The future is moving fast. Let's make sure it moves in the right direction. Please like, share, and subscribe our channel for more updates in AI and technology.